Right, for the trend of boiling point between group 5 and 8, let's use the third period, phosphorus to argon. And let's firstly decide what they look like. Start with chlorine, Cl2, diatomic molecule. Argon, single atom, because it already has a full electron shell and can exist on its own. Sulfur has actually multiple molecular forms, one of which is S8. Let me skip drawing that. Phosphorus exists as P4, which looks like that. And then, what's the nature of bonding behind these four gases? It's van der Waals, right? And then the strength of van der Waals is purely affected by the size of the molecule, which tells us that the sulfur will have the highest boiling point, followed by phosphorus, chlorine, and argon. And then if we try to illustrate this on the graph here, where we say this is the boiling point, where the y-axis is the boiling point, we can say phosphorus is the second highest, chlorine, argon. So we can have a trend like that. That doesn't really have a regular trend, right? That's for the third period, but then we need to talk about the second period because it will look differently to the third period. So let's look at what nitrogen, oxygen, fluorine look like. These guys actually are all diatomic, right? N2O2, F2, and then the neon singular atom. So their van der Waals forces are actually very similar. If we have to really go into the specifics, fluorine will have slightly stronger van der Waals than oxygen, and oxygen than nitrogen. So for the second group, we can say that the fluorine is the highest, next oxygen, nitrogen, and neon. Neon having the lowest boiling point. So for group 5 to 8, we can say that the boiling point really depends on the molecular structure of the atom.